Hi everyone, hope you're having a great day today. We're going to look at chapter 11. So basically all of the chapter before we only learn about right triangle and how to operate with right triangle. So now we're going to look at how to apply the concept that we learned for scalene triangle, and scalene means no sides and angles are the same. So you will not be able to use the Pythagorean theorem anymore because you do not have a right angle anymore. So we have the law of sine to help us dealing with scalene triangle. So let's look at the fundamental of congruence axioms in order to help us determine how to apply and when to apply the law of sine. So congruent axiom means that if two triangles have the same side, angle, or side, then they must be congruent. So congruence means the same, and similar means the same shape but not the same size. So for example, here I have two triangles, and all you know from these two triangles is that this side equals this side equals this side equals this side. So if that's true, then that means that these two triangles are congruent, or they are the same triangle. Okay. Now we cannot say the same thing about angle, which is why you do not see angle as a congruent axiom. For example, the reason why that is if I draw this triangle and I draw this triangle. Now you can see this side, I'm sorry, this angle is the same as this angle. This angle is the same as this angle, and this angle is the same as this angle. If I claim that, that is not true, that these two triangles are exactly the same. You can see that they are not because they have different length, right? The side length. So angle is not a congruent axiom. Okay. All right. So side, angle, side. So here, if I have a triangle that have the same side, angle, and side. So here, this side is the same as this side. This angle is the same as this angle, and this side is the same as this side. So the reason why we have to have the same triangle is for the following. Now, since we have two sides already, that means that this length right here, this length, this angle, and this angle can be whatever it needs to be in order to create a triangle. Well, the thing is that since we have a fixed length here and a fixed length here, that means that this side right here have to be a certain length so that it meets with the vertex of here and here. Well, if that were to occur, then that means that this angle have to be created and is fixed, and this angle is also fixed. So that means that if two triangles have the same side, angle, and side, they must be the same. Hence, we call that the congruence axiom, and this is one of them, side, angle, side. And you can see similarly angle, side, angle for the same reasoning that these two triangles must be the same if you have angle, side, and then angle. Now, anytime that we use any of these congruence axiom, when we say side, or angle, side, angle, they must be next to each other, okay? So what I mean by that is that if I say side, angle, side, you have to use this side. If you choose to use this angle, then the next side have to be here. You cannot choose this side, okay? So side, angle, side, they are adjacent to each other, okay? So I cannot say, for example, I cannot say side, angle, and then choose this side, okay? That's not true, okay? Or I cannot say this side, angle, and then this side, okay? That's not true. It's not adjacent to each other. Okay, now if I have that, let's see what happened. So here, one side and two angles are known. So if I say side angle side or angle side angle or side angle angle, that means that one side and two angles are known. Okay, so here are the different scenarios that you can have. Now, we're going to discuss side-side angle and why this is an ambiguous case, and I'll explain why that is called an ambiguous case. Here we have the case where we know two sides and one angle, called side angle side, and here we know three sides are known. We need to find out what is the angle. Okay, so in order to derive the law of sine, we have to have the understanding that we can. The reason why we use the law of sine is the following. Anytime we have a triangle, we always can find the height. The height of a triangle is defined as the base and perpendicular to the highest point, which is the vertex. So here the height is inside our triangle, but that's not necessarily have to be true. Here we see that the height is outside of the triangle, but you can see it's true because the base is here, extended outward, perpendicular to the highest point, which is our vertex here. So if you rotate this triangle, and let's say that this right here is my base, then my height would be right here, perpendicular to the base. So here we have three different heights, depending on which base you want to find, okay? All right, so the reason why we have the law of sine, the motivation for it is that we use the corresponding angle to the opposite side. So if you look at how they label this triangle, notice that anytime we label a triangle, the angle always correlate with its sides. For example, side C, lowercase c, angle C. Side A, lowercase a. So over here, this distance, we would call that side B, okay? Because here the vertex is B. So in order to figure out the ratio between angle A and side A, we use the height in order to determine what that is. So if you look here, we have sine A. So let's look at the derivation of it. So here is my angle A. So sine of A is opposite over hypotenuse. So here we have opposite over hypotenuse, or we can solve for H. And sine C is opposite, which is H over A. Here we have H over A, or H equals A sine C. Now, since these two H are the same, we can set them equal to each other. So we have C sine A sine C equals to C sine A, or we write it as a ratio of its angle and its opposite side. So this is now the law of sine. So it's very easy to remember because we have A over sine A, B over sine B, C over sine C. Or you can actually flip it, since we have a ratio, we can actually say sine A over A, sine B over B, sine C over C. This is because if you see, we have a proportion. We have 1/2 is equal to 4/8. That's true, but if we flip it, this ratio is still true. So if I flip it, I have 2 over 1. If I flip this, I have 8 over 4. That's still true, right? So if we flip this, we still have the same original law of sine. Now, why would we want to pick this one over this one? Well, that depends on what you want to solve. If you want to solve for the side, you use this. Or if you want to solve for angle, you would use this one. Now, whatever you want to solve for, you want to put it in the numerator so that it is much easier to solve for. Okay? All right, so let's look So I'm going to not show you that. And we're going to practice sketching this triangle. Okay. So anytime you sketch a triangle, remember that we always draw the angle, and opposite of that is a lowercase we use for side. Okay, so we use capital letters for angle, lowercase letter opposite from it to denote the side. So the B and C here doesn't really matter. You can put it however you like. Now we need to label it. So angle A is 32 degree. Angle B is 81.8 degree. And A is equals 42.9 centimeters. Okay, so now let's talk about how do we know to use the law of sine instead of something else. Later on, we're going to look at the law of cosine. So how do we distinguish the difference between the two, and how do we know when to use the law of sine? So here's a hint. Use law of sine when you can create a ratio of the angle to the opposite side. All right, so what I mean by that, here I have angle A, here you are given side A. So that means I have a ratio that I can use in law of sine. Now, I can easily find angle C, so I don't really need a law of sine for that, because we know that the sum of all of the angles of a triangle equals to 180 degrees. So I know that 32 plus 81.8 plus angle C is equals to 180 degrees. So go ahead and find C. Type the answer in your chat. I'll give you a minute to catch up. And write the answer in the chat when you're done. All right, Elena and Mohammed got 66.2. Very good. Okay, so let's label that 66.2 degree. All right, so now I can find C or B. Okay, so in this example here, it doesn't really matter which one you solve for first. All right, so let's solve for B. So B is the variable that I want to solve for. So I'm going to put it in the numerator. Okay, now I need to fill in the rest of it to create a ratio. So B over sine B, well, angle B is 81.8 degrees. And now I'm going to use a ratio that I found, which composed of A, 42.9, and sine of 32 degrees. So in order to solve for a proportion problem like this, or a ratio problem, we multiply these two, and then we're going to divide by this. So B is equal to 42.9 sine of 81.8 divided by sine of 32. Now be careful when you use your calculator. Okay, warning. You always write the coefficient in front of trig functions. What I mean is this number right here, you need to write that in front of sine and not sine of 81.8 times 42.9. This is wrong. Do not do this. If you do this, you're going to have the argument of sine be this product here, because the calculator is going to think you meant this. Okay? So be very careful if you are going to use this, need to put parentheses around this number. Okay, so just to be safe, always write the number or the coefficient in front of the trig function. All right, so if you are going to use a calculator without the fraction function, you need to put parentheses around the numerator and then divide by sine of 32. So if you're going to type in your calculator, you should do this. Parentheses 42.9, sines of 81.8, divide sine of 32. Okay, and what do we get here? B is about 80.1 centimeters. Did we get 80.1? And then we're going to do the same thing for C. So go ahead and set up C and solve for C as well. Raise your hand when you're done and type the answer in chat.
Professor, what are we solving for after B?
We're solving for C. C is the last thing that we don't have yet.
Okay.
Yeah, so we found B. We already have A. Now we need to find C. Now we're going to use the same ratio, 42.9 over sine of 81.8, because this is given. Okay, so another warning I want to give you. Always use given information if possible. Sometimes it's not possible to use a given information. That means you're going to have to round. So the reason why we always use a given information, because it is exact value. If we are going to use something that we found, then that means we probably rounded that. So if we do that, we're going to come up with a rounding error. Okay, so that's called round off error. Okay, so round off error occur when you use values that was rounded off. So the error will compound if you do it multiple times. Okay. All right, so anyone have a value for C? Elena, you have a question? You done?
Yes, I'm done.
So you got 39.3 for C, right?
Yes.
Not quite. They got 74.1. So let's see what you did.
Yeah, I'm confused now.
Okay, so let's see. Oops, I wrote something wrong. Haha. I wrote this wrong. This is supposed to be 32. Did you put in 81.1.8?
I think I did.
Yeah. Yeah, because we need to find the ratio, which is 42.9, and A is 32 degrees.
Okay.
So, yeah. And then C is sine of 66.2. Yeah. So make sure you have C over sine C and A over sine A. And that will give us this ratio here. And if you do that, you should get 74.1. Is that okay?
Yes.
All right, so let's look at this word problem here. And I'll give you a minute to try to do this one.
Professor, how do we go from having our ratio to writing it as the equation? How did you do that?
Okay, so anytime that we have a ratio, and whatever the unknown is, we're going to put it here, and then the ratio of that unknown. Okay, so if I have, for example, let's look at this problem here. So we know that angle C is 112.9 degree. Angle A is 31.1. Find distance A. So this is my question, right? This is the distance I want to find. So that would go on top of here. Okay. So remember that the ratio A over sine A, B over sine B, and C over sine C. So whatever the ratio that we have, we're going to use. So in this example here, we know A, we know angle C, so we can actually find what angle B is from 180 minus this and this, right? So let's find it, right? So 180 minus 112.9 minus 31.1, what does that equal to?
36.
36. So we know that B is 36 degree, and you could also see that we know sine B. So that means the ratio that we're going to use is going to be B and sine B. Okay, so I want to find A. A goes on top here. Then sine A go below it. So A here is 31.1. All right, now I'm going to use the ratio that was given to me, B over sine B. B is 347.6 over sine of 36 degree. Now I can do cross multiplying like this and then divide by sine 36 to solve for A. Does that make sense?
Yes.
So A equals to 347.6 sine 31.1 divided by sine of 36. So type that into your calculator. Make sure you put parentheses where appropriate. By what you get. Mohammed, you have a number yet?
What are we rounding to? Just to the 10th?
To the 100. So 2 decimal places.
2 decimal places.
Normally we only round to 1 because we only have 1 here, but I just want to see what you guys got. So do we get 305.5? All right, very good. 305.46, that's good. Excellent. All right. Okay, so I'm not going to give you the picture because I want you to practice doing it without the picture and see if you understand what's going on when we are dealing with bearing. So remember that anytime we say bearing, is going to be from due north, okay? Or if they say north east or southeast or southwest, whatever, then it's due the north-south pole. So what I want you to do is just to sketch this first and see if you can do it. Are you guys in the whiteboard? No? So come to the whiteboard. And without peeking, try to draw it somewhere out here to the right of the problem. So maybe I'll divide it into 4 for you. And then you just zoom in and try to sketch it, okay? So just claim your spot. Let's see, maybe Elena will take this one. Mai take this one. Mohammed take this one. Mohammed, you can join us?
I couldn't get to the whiteboard.
Oh, okay.
Professor, I need to ask a question. Would you show me again one more time how to go ahead and put these numbers on the calculator when you're finding this?
Okay, sure. What kind of
maybe
calculator do you have?
I have a TI-84. I may be wrong on the way to put on the parentheses, I guess.
Okay, sure. All right, I'm going to show my calculator and show you how to do it.
Thanks, sir.
Mm-hmm. I'll give you a second. All right. So the first thing you want to do is go to mode and make sure that it's in degree. I think that's maybe the problem.
Oh, it was, yes.
Yeah, because we're doing everything in degree mode, so you have to make sure that it's in degree first. And then let's see, we're solving for, I think was it sine or
Yeah.
something. So let's type in there. So we have 347.6
Okay.
times sine 31.1.
So we
Close
don't put the
parentheses.
parentheses before the coefficient.
I'm sorry?
Do we have to put the parentheses before the coefficient?
No, you don't need to do that.
Okay.
Then divide by sine of 36. And you should get 305.46. There you go. So did you mean parentheses around the 347.6?
Yeah.
No, you don't need to do that. Now, if you have more terms, then you would need to put it around the 347.6 and 31.1. Okay.
Yeah, I got the number now. Thank you so much, sir.
Yeah, you're welcome. Okay. Okay, Mom, since you can't draw it on there, just draw it on your paper.
Yeah. Okay. Can you show me the problem again one more time?
Oh, sure.
I am very lost on trying to visualize what this problem is saying.
Okay. So, all right. So say two stations are on an east-west line. Okay. So east-west line is just a horizontal line. So the first thing you should draw is draw a horizontal line and then put two axes for the two station. And then the distance between those two would be 110 miles. So have you done that part yet?
Yes.
Okay. So a forest fire is located on a bearing of north 42 east. So north 42 east is what quadrant?
North 42 east.
Yeah. What quadrant is that? So if you look on the screen on the whiteboard or blackboard, so we have north, south, west, east here. Okay, so in the first quadrant is northeast, second quadrant is northwest, third quadrant is southwest, fourth quadrant is southeast.
Oh,
So
okay.
anytime they give you a measurement of this and it's a bearing, it's always measured due north or due south and in that quadrant. So here 42° northeast would go like this. From here to here would be 42°. It is not in standard position like we normally do from the positive x-axis. It's from the north and south pole. Does that make sense?
Yes.
Oh, okay,
Okay.
I got it.
Yeah. And then the other one is north 15° east from the eastern station at B. So go ahead and label it and see. Do you need any more help? All right, so let's look at an overview on what we're trying to look at. Okay, so two stations on an east-west line. So we see here that it is on an east-west line, which is just horizontal. Okay, I need to mute somebody here. Thank you. All right, so we see that they are 110 miles apart. A forest fire is located at a bearing of north 42 east. So you see here, north 42 east, measure directly from the north. Okay, so here is the forest fire, and the bearing of north 15 degree east. So here, from the second station, we measure from here to here. That is 15 degrees. And so we can figure out how far away this fire is from the western station. So this is the western station. This is the eastern station. So we need to find out what B is equal to. So we should probably redraw this triangle so that we don't have a bunch of these unnecessary things here. So here we have this triangle. Now, since this is 15 degree, I can add 90 to this to get 105 degrees. So since this is 42, from here to here is 90, so 90 subtract 42 is 48. And of course, since I know two of them, I know the third one is 27 degrees. Now, since I know all three of them, okay, it's very easy for me to solve for any other sides as long as I know one of the sides. And I do, which is the distance from here to here. So now I have a ratio. Oops, that's not a degree there. Right, so 110 miles. So now I have a ratio of 27 degrees and 110 miles, and I want to solve for B. So B is my value I want to solve for, so that would go in the numerator, divided by sine of that angle opposite from it, so 105 degrees, and one of the ratio that I know. So here I know this ratio, so make sure that you put sine also on the bottom, so they must match. Okay, so the side go with side, the angle with that angle. So the angle here is 27 degrees, and I know that it's 110 miles. So now we can solve for B, which is 110 times sine of 105 divided by sine of 27 degrees. Anybody have a number? Oh, good job, Alina. You got it right here. And let's see what they got here. 234 miles, about. Did we get that? Anyone?
I hadn't solved it yet.
Okay, but you set it up right. Did you set this part up correctly?
Yes.
Okay, yeah, you set it up right. That's the most important part. All right, let's continue. Okay, so now in order to apply the law of sine, so let's review everything here. So here we have, for any angle, sine must be between 0 and 1. If sine of theta is equal to 1, then you just know that theta is equal to 90 degrees, because sine of 90 degrees is equal to 1. If we do that, then the triangle is a right triangle. If we have a right triangle, then we just use SOHCAHTOA. Now, we know that supplementary angles have the same sine values. So this is because we know that the first two quadrant 1 and quadrant 2, sine is positive in both of those, right? So if you remember that, for example, whatever this angle theta is, its reference angle is here, and they have exactly the same degree because all we do is reflect across the y-axis to find out what that value is, right? So this is why this is true. The smallest angle is the opposite of the shortest side. Well, this is just the rule of the triangle, and the largest angle is opposite for the longest side. So this here, okay, is just the rule for all triangle. Okay, it's always true. All right, so now let's talk about the ambiguous case. So this is side angle, or you can think of it as angle side. Hehe. No? All right, so this is the ambiguous case. It's ambiguous because we don't know whether we can have 0, 1, or 2 triangle. So that's why we have to check. Okay, so you can see here we have the angle, the side, and the side. Okay, so now we have to make sure that it satisfies the following condition right here in order for us to create a triangle. Okay. Okay, so anytime that you have side angle or angle side, then we have to make sure we know what the height is, and we're going to compare that third side with the height. All right, so let's look at the possible cases. If that third side is less than the height, then there's no way that you can actually extend it long enough for us to create a triangle. So therefore, we don't have a triangle. Another way we can test that is just to take sine B is greater than 1. Well, it's impossible for us to have a triangle when sine B is greater than 1, so therefore we cannot create a triangle. But the easiest way to find it is using this inequality. If my third side is equals to the height, then I know that it has to be a right triangle. If my third side is too long, or basically longer than B, then this side basically swing outwards here so that it can create an obtuse angle. So the obtuse angle is here. Now this is the most fun case here. If my side A is greater than H but less than B, the side can swing either outward or inward to create two possible triangles. So one of the triangle like this when it swing outward from the height, and the other triangle swing inward from the height. So here's the height right here, and this is the third side. So you can see here, this side right here is the same as this side, okay? Now, we have to be careful of sketching our triangle. That's probably the hardest part, so that you can see which possibility it could be. All right, so here is when we have an obtuse angle for angle A. If we have an obtuse angle, then we have to make sure that this side A is the longest length, okay, larger than B here, so that we can create a triangle. But if A is too short, which means it's shorter than B, then therefore we cannot create a triangle. All right, so let's try to see if we can practice that. So I'm going to write it over here. 55 degree and 40 minutes. And then side B here is 8.94 and A here is 25.1. All right, so we're going to practice how to sketch this, okay? So ambiguous case. How do we know it's an ambiguous case? So here we have an angle, a side, and a side. So now we have an ambiguous case. Okay, so let's try to sketch it. So anytime you are sketching this, I want you to sketch it like this. Okay, sketch it like this. The angle will always go here. So whatever angle it is, okay, this time is B. Doesn't matter if we call this one B, C, or A, whatever. The angle always go in this corner, bottom left corner. So this is going to be B. Let's label it 55 and 40 minutes. All right. So now we can kind of complete our triangle. So this side right here is going to be the swinging side. So this side right here has to be B because it is opposite from it. So this side would be 8.94. Now don't draw the triangle because we don't know if it creates a triangle or not. And the third side, whatever value it is, we're going to put it over here, 25.1. So that means that since this is A, that means that the angle down here has to be A. If that's A, that's B, then this has to be C. And this has to be side C. So I'll pause here if you have any question on how to sketch this, okay? Okay, so the angle always here, the opposite of the angle, and then the other side here. We good? Ask questions, guys, because this is kind of confusing.
Yeah, do we now need to take this triangle and look at it with all those what should we call those? The triangles we were just looking at, the swinging sides, would we now?
Yeah. So I am setting it up so that we can check that. So
Okay.
that's what I'm going to do next. Yeah. But right now, I just want to ask you if you have any question on how to draw it, how to sketch it, and then I'm going to test it to see whether it is a 0 triangle, 2 or 1 possible triangle. Okay,
Do
so
we
now
always need to make the B length not the full triangle?
no, whatever so the first thing you need to sketch is this angle. Whatever A, B, or C, doesn't matter it is. The first thing, the angle should always go here. Okay, and then remember that anytime you draw a triangle, if the letter is here, the capital letter is here, the lowercase letter has to be opposite from it. That's why I did not put A here, right? Because if this is B, this has to be B. If this is A, then this has to be A, lowercase a. Does that make sense?
Yes.
Okay.
On the problem, are they gonna go ahead and just give us an angle all the time, or 2 angles or more sometimes?
They give you a lot of different scenarios. You have to know which one to use. Like the 5 different scenarios I gave you from before: angle, side, angle, side, angle, side, 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 or angle, side, side. So they give you a lot more than just these. We're gonna go over 2 more when we talk about law of cosine. So you're gonna have about 6 of them to memorize. So you have to know which one to use with what. Okay, but I'm gonna give you an easy way to memorize them. Okay. When I introduce cosine, I'll summarize everything. Okay?
Thank you.
All right, so now we're going to look at how to determine whether I have 0, 1, or 2 triangle. Okay, so we need to find the height. The height help us determine this, okay? So the height is right here. So let's think of how to find this height. Well, if I draw that, you can see here, this is angle B, okay? This is 25.1, and I know that this is 55 and 40. Can you find this height? That's very easy, right? That's just the law of sine. So sine of 55, 40 equals to opposite, which is the height, divided by 25.1, which is our hypotenuse. So h is equal to 25.1 times sine of 55 degrees and 40 minutes. Do we know how to input minutes into your calculator?
Don't we have to divide it by 60?
Why 60? Where's 60 at?
I don't know. I thought that's how we made it into like a decimal. Or am I
Oh,
completely
this.
wrong?
Oh. No, you don't have to. You can just type this directly into the calculator. You don't have to convert it. You can if you want.
No, I don't.
Yeah. So yeah, 40 over 60. That's fine. So you're just going to convert that to decimal. Yeah. So 55 and 2/3. All right. What do we get for height? Anybody? What's taking so long to type it in?
Is that 20.7?
Huh? What you get?
20.7?
20.7. Okay.
I got 14 point. I think I did it wrong.
Uh-oh. Oh, well, let's see. Now let's see what they got. What is H here? Did you not put H here? That's okay. All right, let me use my calculator.
How do you type in the minutes? Like,
Oh, press second and app. You see it? Number 2. Yeah, you got 20.726. That's right.
yeah, I typed it in wrong.
Wait, didn't you get 20.7 though? Or was
No,
that wrong? Oh, okay.
it was
So yeah,
wrong.
so we got 20.7. All right, so what unit are we using? Do we have a unit? Meters. Okay, meters. All right, so let's look at what we have here. So the height is 20.7 meters. All right, you see this leg right here? You see this side is only 8.94. So that's why I drew it like this. 8.94 is not long enough for me to reach the bottom here to this side to create a triangle. So this angle right here is free to swing however it wants to. It can be down here if you want, or here, or here, or here, whatever. But you can see it's not long enough to reach this third side. Therefore, we have 0 triangle. So we cannot solve for this one, because our side is less than the height. Is that okay?
So it does not exist.
It does not exist. Triangle does not exist. Okay. All right, let's try the next one here. So I'll do it over here. We have A equals 55.3 degrees, A 22.8, B 24.9 feet. All right, so that's all you get. I want you to try to sketch that for me. Mai, you still here? Okay, I'm going to divide this in half. Elena, you take one side. Mai, you take one side. All right, very good. Good job, Elena. So what can we conclude here?
That's what I'm confused on. How do we compare it to the
Okay.
triangles to see whether or not it has a possibility?
Okay, so let me explain that. All right, so let me try to redraw it here. All right, so we have 24.9, and then this angle right here is 22.8, and this height right here is 20.47. All right, so let's try to imagine that I have, I'm going to extend this one right here, right? Because this here is only 20.47. So that means that 22.8 is longer. So it's going to go outward like this. Now, 22.8 is not longer than 24.9. So that means it can actually swing inside of the triangle here, therefore creating two triangles. So remember that this length, let's see, this length right here is arbitrary. It can be as long or short as we need to be. This angle right here is arbitrary. It can be as small or as large as we need it to be, because we only have three things that are fixed. We have this angle right here, this side right here, and this side right here. So this angle, and this side. That's the only three things that are fixed. The other three things, okay, can be as long or short as we need it to be in order to create a triangle. So the two triangle that we can create is this one, which is an obtuse triangle, because this one will be an obtuse angle, and an acute angle. So this is the one that swing outward. This is our height right here. Does that make sense? If this
Yes.
value here is larger than 24.9, that means we cannot swing inside, because that leg would be too long. Like if you swing inside, the leg would be all the way out here. Okay, so we cannot create a triangle like that. All right, because this angle is fixed. It can only lengthen it or shorten it. It cannot swing. So this angle is fixed. So that's why if you have the swinging side larger than this side, we have an obtuse angle. So it's going to swing outward like this. Okay? So in this example here, it's kind of obvious that I cannot take this length right here and swing inward. If I swing inward, you're going to have this case right here, which you cannot create a triangle like this, because this angle here is fixed. Okay, does that make sense?
So in that case, we'd only have one possible triangle.
No, we have two. I just drew it right here. Two.
No, I'm saying if it was a longer angle and
Oh,
you
yes,
were
yes,
zooming
yes.
in.
Yeah, if this side is longer than this side, we only have one triangle. Exactly. And it looks like this. Yeah.
Okay, I understand.
Yeah. Okay, great. All right.
Excuse me, sir.
Yes.
So do we say the left side is always fixed?
This angle right here is fixed. Yes. Is this what you're talking about right here?
Yeah, all the way up to the top.
This angle is not fixed.
Okay.
Yeah, look at right here. Look at the original picture here. Okay, so it's angle side, right? So this angle, I'm gonna try to use a more
Okay.
colorful.
That's side.
Yeah, this angle is fixed. This side is fixed. This side is fixed. That's it. Okay.
Oh, okay. I was talking about the left side, the whole left side.
Yeah, this left side right here.
It's fixed.
Yeah, that's fixed. Yeah, because 24.9, that's fixed.
Yeah.
Yeah, this one is not fixed. Okay, this side is not fixed. Okay, and yeah.
Yeah, that's good. So we're gonna go ahead and always compare the right side to the left side.
Yeah, so we're going to check to see if this one right here, we're going to compare to the height to see if there's a triangle. If it's greater than it, then we're going to compare it to this one to see if we have one triangle or two triangles.
Okay, I got you.
Okay. All right.
Okay.
All right, so now we're going to do the swinging outward triangle first. So we're going to do this one first. So here we're going to redraw this triangle and let's label it. All right, so we know the angle is, forgot the angle. What is it? 55.3 degrees. Let's zoom out a little bit. Oops, too much. All right, so we have, let's see, that's angle A. So side A is going to equal to 22.8 feet. And over here we have B at 24.9. So that means that this is B, this is C, this is side C. All right. So this is what we know so far, right? This is all we know so far. We have 3 known. We need to solve for it. So we need to find the other 3 unknown. So the unknown would be angle C, side C, and angle B. Well, we can solve for angle B because we know what side B is equal to. So solve for angle B. So we do sine of B divided by side B, 24.9. You see, this time I put the angle in the numerator because my unknown is an angle. And I'm going to use my ratio. My ratio here is sine A, which is 55.3, divided by 22.8 feet. Okay, so now I need to solve for sine B. So let's move the 24.9 over. All right, now to solve for angle B, I'm just going to take sine inverse on both sides. All right, then type all that into your calculator, and B is equals to, so I'll give you a minute to do that. All right, great. 63.9. So let's see how many decimal places we have here. All right, since we only started with 1 decimal places, so we're only going to round to 1 decimal places. All right, so B is going to be 63.9 degrees. All right, so since we know that, we can solve for the rest of this, right? So we can solve for angle C next because I have 2 of the angle. So I'm 180 minus 63.9 minus 55.3. And tell me what that is. And then once you know what angle C is, you can solve for side C by doing the same thing. So we're going to call side C, sine of whatever C happens to be, angle A 22.8 divided by sine of 55.3 degrees. So what is C? So I'm also going to give you a warning here. So if you know 2 of the angle, always subtract from 180 to find the third angle. Okay, the reason why that is you always have to add up all 3 of those angles to equal to 180 degrees. Okay, so you cannot have the sum of 3 angles to equal to 179.9. So if you're going to round off one of them, then you have to round the other one as well. So what do we get for C? 60.8. All right, so we're going to use 60.8 in our equation here to solve for C. So go ahead and finish with C. And then we'll be done with half the problem. Then we have to do it for the other half.
Do we still need to be using the inverse of sine?
To find C or what?
Yes.
No, because C is just a side, so you just have to multiply, sine C up here. So 22.8 times sine of 60.8. You're not solving for an angle, you're just solving for a side.
Oh, okay.
All right, what do we get? 24.2 for C. Okay, anyone else confirm that? Let's see if we got it right. So that's only half of it, right? So 24.2, very good. All right, well, that's half of the problem because we only solved for one triangle. Now we need to solve for the other one, which is this one right here. But one will go much quicker because we already found a lot of the stuff already. Okay. All right, so let's draw the other one. Okay, so here's the one that swings inwards. So let's label the sides again. 55.3. We got 24.9. And this one was 22.8. All right, so let me show you something that makes this go a lot quicker, okay? All right, so when we swing outward, we have this triangle here. And when we swing inward, we have this triangle here. Now, the one thing that you need to realize that this side is the same as this side. So if I'm looking at the triangle here, what we have is actually an isosceles triangle, which means that this side and this side is the same thing. Now, we just solved for this side right here, right? That side happens to be angle B, right here. And we solved that to be 63.9. Now, if I swing it to the inside, well, this is 63.9. This is also 63.9, which means that the other angle is the supplementary angle. So I can find that easily by taking 180 minus 63.9 degree. And what do we get? One 16.1. So now this angle is 116.1, which means that this angle is 116.1. It's the same angle. So now that we know that, we can definitely find this
Can you
one.
repeat that logic?
Sorry?
Can you say one more time that logic from 63.9 to 116.1?
Yeah, because they are supplementary. So if I draw a straight line, and if this angle right here is 63.9, this entire thing here is 180 degree, right? Because it's a straight line. Then you take 180 minus 63.9, you get this one, which is 116.1. Right? No?
Yeah, I see.
Okay. All right, so if I know that, then I can find out what the third one is. So here, I can find out this angle, which is 180 minus 55.3 minus 116.1. What do you get for that? So I got 8.6 degree. Okay, so we're almost done. All right, so let's label some of the side here. So the angle here is A, and this one here is B. This is C, B, A. So now the last thing I need to do is find C for this triangle. And we're going to do the same thing as we did before. C divided by sine of C, which is 8.6, equals to our ratio, which is 22.8 divided by sine of 55.3 degrees. So C is equal to 22.8 times sine of 8.6 divided by sine of 55.3. What do we get? I got 4.15 or 4. Excuse me.
Bless you.
Thank you. All right, so since we have two triangles, we have to find a different notation to distinguish the difference between the two. So normally we use this notation here. So the given, we have A, lowercase a, or the side A, and what was the other one? And B. Let's just move it over here. So A was 55.3 degree, A was 22.8 feet, and B was 24.9 feet. All right. So the first triangle, with this one that's swinging outward, okay? So we solve that one, and let's find out what is our unknown. We need to know what is angle C. We need to know what is angle B. Let's write B first here. Angle C inside C. And we also need to know if it's swing inside. Then we're going to use the terminology B prime, C prime, and C lowercase prime, just to distinguish the difference between the two of them. So we use prime. So B was 63.9, C was 60.8, and C was, let's see, 24.2. And then the other one, the angle B was 116.1 degree. C prime is 8.6 degree. And the last one was 4.1 feet. So this is our solution here. Let's check if we did it right. We got 4.15 feet. Yep. Any questions I can answer? Okay, you want to do another? We are going to do another one. Ready to move on, or you need more time?
You go ahead and move on because I'll definitely go ahead and review the whole recording.
Elena, you good to go?
I'm good to go. These problems are just a lot longer than I would have expected.
Yeah, when you have two triangles, it's a lot longer. Now, when you have one triangle, it's not that bad. So here we go. So go ahead and try this one. Make sure you sketch it as well. So find an empty spot, maybe on the left of this, and sketch it. Sketching it is probably the hardest part. What, Elena, did you check to see if you have 1, 2, or 3 triangle? I mean, 0, 1, or 2 triangle. You can't have a triangle.
No, I thought I was supposed to do that afterwards. Oh,
You do that.
wait. I've got to find my height first.
Yeah, you can find your height.
Darn. Hold on.
Well, here's the thing. If your third side, your swinging side, if that one is greater than the other side, then it has to be greater than the height. So you don't have to find the height in that example. Oops. Whoa, stop. Okay.
Wait, then I'm confused.
What are you confused of? Okay, so let's sketch this triangle, right? Okay, so they're given A. So again, our angle always going to go down here. So that's A, 43.5 degrees. That means that side A had to be here. So that's 10.7 inches. And side C, 7.2. So that means C here, B here. Okay, so you see this one right here, the swinging side is larger than this. So that means it has to open outward like this.
Oh, okay.
Yeah. So we cannot swing inward because it's longer than this side. So we know that we only have one triangle. Is that okay?
Yeah, looking from the given, we already see that the right side is already longer than the left side.
Right. So this one is already longer than this one. So that means it has to be longer than the height, right?
So we can skip
So it's
over
not
the
possible. Exactly. You can skip over checking to see if the height because we know it's going to be longer than the height because it's longer than this side. Does that make sense? So we only check to see if we have 0, 2 triangle if this value right here is less than this side.
Okay.
So we have to check to see if it's longer than the height first. If it's shorter than the height, we're going to have 0 triangle. If it's longer than the height but less than C, then we have 2 triangle.
Oh, okay.
Okay? So this one we have only 1. So now you can just go straight to the law of sine. Awesome. Good job. Okay.
Uh,
Yeah.
am I on the right direction to solve for sine C? If I put sine C over 7.2 equals sine A is 43.5 over 10.7.
Say it slower. Say it one more time.
Sine C over
7.2.
is equal to sine A 43.5 over 10.7.
Yeah. So you have over 7.2, right? 27. Sine 27.6 divided by 7.2. Right. So let me write it for you. So you're trying to find angle C, right?
Yes, sir.
Okay. So if you're trying to find angle C, you should put sine C divided by 7.2 equals 2 sine of 43.5 divided by 10.7. So this is known, this is known, this is known.
Yeah.
Okay.
Okay.
Okay, good. Alina got 29.7. That's good. Side B, you got 14.9. Okay. Now, let me ask you if you round in the places. What did you find first, Alina?
I found all my C values first.
Okay, so what was your exact value for C?
For C,
Yeah, you got 29.7. They got 29.6. So I wonder if you rounded up. So if you, what is your second decimal places to find that?
hold on, I went back in my calculator and reused the equation, so hold on.
Yeah. So you set it up correctly. It's this right here. I just wonder how you're off by one decimal places. Mohammed, did you get it? Did you solve for C yet?
I think maybe I just typed, wait,
No, you're pretty close. I think it's something to do with rounding.
well, I just did it again and I got a whole completely different answer. Oh, yeah,
See, sine 43.5, 10.7. I got 27.59.
that's what I
So
just got too.
yes, so you should get 27.6. So I see you got 29.7.
I must have typed something in wrong.
Yeah, so that's gonna mess up all your other values here. So let's see right here.
Dang, this is like one wrong move and the whole problem messed up.
I know, that's why you should write all this stuff down so you can get some partial credit. So yeah, so anytime you do problem like this, make sure you write down all your steps so that if you get something wrong like this and then you go to the next part, it's still going to be wrong because you're using values that you just found. So you do one little decimal somewhere, or you round somewhere wrong, it's going to mess up the entire problem. So you have to be very, very careful anytime you come up with something like this. All right, do we have finally the answer for B and angle B? So angle B is easy because you can just subtract that from 180. So you should get 108.9 once you do that. Once you change this one to 27.6. All right, and then we can use the law of sine again to find B. So change this one right here.
I got 14.7,
That's
which is
right.
funny because I had 14.9. I was just 0.2 off.
Yep.
Wow.
So one little move, yeah, it should be off a little bit. All right, so let's wrap that problem up and let's look at this here. So let's discuss it. Okay? Maybe draw it out, that would help. So without using the law of sine, explain why A equal 104 degree, side A 26.8 meters, and side B 31.3 meters cannot be valid for cannot be a valid triangle.
Are we supposed to talk about it and why
Yeah,
it's not?
let's discuss. Yeah. But why don't you draw a triangle and then maybe that be a
Okay.
nice visual aid for us. Draw somewhere on the right. Yeah, let me erase this part here. Okay, so yeah, I guess I'll draw it and then we can discuss here. A is 104, so I'm going to try to draw it so that it's kind of resembles it. So A here, so this is 104. And we have side A, which is 26.8 meters. And B, so B could be either one. So let's say this is B. So this is B here, is 31.3 meters. All right, why this cannot be a triangle?
Because you'd need side A to be longer than side B.
Why is that? What's the
Because
reason?
I don't. Because they would just look. It's just
Looks weird.
wrong.
Well, you're right, but you have to understand why. We actually went over the property of triangle before.
Isn't it the largest angle and the largest side?
Yes, that's true. Now, how do you know 104 is the largest angle?
Because a triangle equals 180 degrees, and there is no possible.
That's correct. You're right. So you cannot have two 90-degree triangle, right? or
Yeah.
two 90-degree angles. In this coordinate system, in the Cartesian coordinate system, you cannot have two 90-degree, but actually, can you think of a triangle that have three 90-degree angles? I can actually prove it to you that we can actually have a triangle that's have three 90-degree. You want to know how?
Yeah, I don't believe you, Professor.
You don't believe me? Awesome. How about you, Mohammed?
I'll tell you what, I'm totally confused. Unless we maybe swing outward. I don't know.
Mai, you still here?
Yes.
Okay. So tell me, what is the definition of a triangle? That's a very elementary question. That's like first grade question. What is a triangle?
Three an angle.
What?
Has that triangle.
It has three angles. Yeah, tri means three, right? So triangle means three angles or three sides and angles. How about that? I'll give you the three sides. Three sides and three angles. Okay. Now, this is at the very most basic definition. Okay. Now, in different coordinate system, what we are learning right now is called the Cartesian coordinate system, where you have x here and y here. You have a point here, and of course, you can create a triangle like this, right? Later on in the semester, you're going to learn something that resembles this. I want you to imagine the Earth. Okay, so here's the Earth. Here's the equator. Here's like the longitude to North and South Pole. Now, I want you to imagine that the intersection of the longitude to the equator, what angle does that create? Anyone? What is the angle that it creates when it intersects with the equator? The longitude intersect with the equator.
Right angle.
A right angle. That's correct. Now, how many longitude are there in an equator? I mean, in like on the sphere here. How many longitude are there? Like you have like a bunch of them, right? Basically 24 for different time zone, but we don't use time zone for that. Okay, so we can divide this into how many pieces we want. I'm going to divide it into 4. So here, so if I were to go all the way around, okay, from here to here, there's another one. That's another longitude right there. That's also 90 degree because any longitude is going to intersect with the equator at exactly 90 degree. Now over here, if I have one piece of the longitude here, one piece of longitude here, I can create another 90 degree here. So imagine that you're cutting an orange into 8 pieces, right? You cut it in half right here, and then you cut it in half again, and then you cut it in half again. So what you have is basically this piece right here, which have 3 sides. They're all the same side, all the same angle, and all 3 of those angles are 90 degree. So there you go. You have a triangle with 90 degree, but the trick here is it's in spherical form. Spherical coordinate system. Okay. So you learn about this later on. There's also cylindrical. Okay. And there's also the complex plane. And what's one more? Oh shoot. Start with a P. What is it? Parametric coordinate system. So you have a lot to. So this will be on our 4th exam. Okay. So yeah, yay. So worry about triangle first. Later on, you're going to look at shape that looks like this. You have a little flower that goes all the way around. Really cool. See? we're going to look at this. We're going to look at a cardioid. That looks like this. Kind of looks like a heart. That's why you call it a cardioid. And then we're going to look at a limosome. This is a fancy word for a type of cardioid. But yeah, you learn about all these shapes. So I hope I didn't scare you, but just so you can kind of see what's to expect.
You already did.
All right, you guys want to do some more examples of this? We're at the end here. We can do some homework or whatever. We'll call it a day. It's up to you.
I'm fine with doing homework or more examples.
Sounds good. Okay, so I'll go find some. All right, chapter 11.1. Let's find some hard problems. What? Why is it only 8 problems? This needs to be like 30 problems. Okay.
No, leave it at 8. 8's good.
The more you have, the more practice. I mean, but you did see like that one problem with the 2 triangle. It was pretty long. So
Yes, as soon as I thought that we were done with it, another thing we had to find.
that's like the joy of life, you know. Come on. Oh, look at that. All right. So here we have solve triangle ABC. We had angle side side. So there you go. Try that one. See if I can zoom in a little bit more. Oops, not that. Control plus. All right, there you go. You guys see that okay? So work on that and let me know if you need help or we need to do anything. Remember to sketch it out. All right, we done, guys?
I am finding angle C and then the side length of C of my first triangle.
Okay. Oh, you have two triangle?
Am I not supposed to have two triangles?
Ah. Mohammed, what you get? Yeah, one triangle or two triangle?
One, because
One?
side, we have only one triangle, I guess.
Uh-oh. Maya, you get one or two triangle?
Oh,
Okay, let's see here. We have B, 34 degrees and 42 minutes. A, 38.3. Side B, 31.1. Okay. All right, let's draw this triangle here. Okay, so this is B, side B 31.1, this A 38.3. All righty, so we see that 31.1 is less than 38, so we're going to have to find a height to check. Okay, the height is going to be
163.
2163. That's
Yeah.
what you got? Okay.
I got
Yeah,
2146. Am I wrong?
Uh-oh. So sine 34.42 equals H divided by 38.3. So let's check. H here is 38.3 times sine 34.
Right, I guess, because I left the 0.3.
Oh, you left the 0.3. Okay, Elena, tell me what you got.
I got 21.46.
4.6. Okay. All right, so we see that this is larger than the height and less than this length, so we have two triangles. Okay, so let's do the one that opens outward first. Let's label that. Okay, so now that means that this one here is A. So let's find out what angle A is equal to. So we have sine A, 38.3 equals to sine 34.42 over 31.1. So A is equals to sine inverse 38.3 sine 34.42 over 31.1. And what you get, Elena?
I got 42.43. But that's like decimal, yeah.
Yeah, that's it. All right, so let me, Mohammed, you want to confirm that? Let me type in, check it. I got 44.51. Uh-oh.
Yeah, not good.
I'm double checking what I did here. Yeah, I got 44.51. So 31.1, 34.42. Now, when you did the angle, did you do 34 and then plus 42 over 60, or did you use the angle in degree?
What do you mean?
Like the notation for the angle in degree.
Oh, I divided it by 60, so I got 34.07.
Oh, I think that may be why. Wait, 3407?
It is 34.7.
No, that's not it. Because 42 is almost 3/4, so it should be about 0.75.
Okay, never mind. Don't listen to me. Just it's
So
0.7.
yeah, it should be 0.7 something. You put 0.07?
Yep. Wow.
Aw.
Dang
Well,
it.
now we found out why. Yeah, it's 34.7.
I'll tell you what, Professor, my machine has rounded to 0.7 automatically when I put 42 over 60.
Oh, okay. Yeah, even better. Yeah, perfect. So we got 44.51. Okay. Oh, I'm sorry, Elena.
It's fine.
Live and
These
learn, right?
dang problems.
All right, so now we can find side B. I take 180 minus 44.51 minus 34.7. All right, let's see what we got there.
Isn't it like 103 point? Never mind. I don't know.
100.79. All right, so now I'm going to find side B. So B over sine of 100.79 equals 231.1 over 34 sine of 34 and 42. And that's 34.7, right? So B equals to 31.1 sine of 100.79 divided by sine of 34.7. So all that, let's see where we get there. I got 53.66. And that should be it, right? That's the first triangle. Now let's look at the second triangle. All right, so since this one is 44.51, I'm going to subtract 180 from that. So I'm going to get 9, 4, 5, 3. Okay. So that's going to be, let's see, A prime. So now I can find B prime from 180 minus 135.49 minus 34.7. (9.81). That's degree. All right, last one, find B. So B is the same thing here. B over sine of 9.81 equals, I got 31.1 over sine of 34.7. So solve for B. And that's our last value. Let's see what we got. Okay, I got 9.308. So just say 9.31. All righty, there we go. We got, this is B prime. Q.
I'm gonna
How do you-
immediately go do my homework, and I'm gonna
Yes.
make sure that I do it very precise so I don't make these mistakes.
Yes. That's my best suggestion. After you learn something, go do it right away to solidify your understanding. And if you're unable to do something or you have questions, then you should ask next time. Don't wait until Sunday or Monday or Saturday to do it, or the day before the test to do it, because you're not going to get the best of this. You cannot crime. I mean, you cannot, what you call, cram. I mean, you cannot cram like the entire chapter of this in like what, a day or two. So yeah.
Yeah, and I'm glad I finally made it to a lecture. I didn't have to work today. So I was like,
Yay.
I can go and ask questions.
Yeah, I'm glad you're here because normally AIM asks questions and he's not here today. So I'm glad you're here. Mohammed's kind of shy because he never asks questions, but you asked 2 questions today, Mohammed.
I'll tell you, I'm usually shy because I'm not an online learning guy. So
Well, yeah, I don't think anybody is. But there's only 3 of you guys in here and mine never talked. So just 2 of you guys have talked. So there's nothing to be shy about. It's just us 4 in here.
Oh
Right,
yeah, I
Mike?
don't understand at all, and I'm gonna make it known.
Yeah.
I have
Just,
to from now till the end of the semester. Now I have to
yeah.
push to do
So don't be
master.
embarrassed or whatever about not asking questions because it only get harder from here. So you can already see how hard and how long each problem is. It's going to get worse.
If I suggest something, is there a way you could just go and just give us a quiz sometimes in the middle of the lesson, so we could just go and you could just go ahead and find out our understanding on some
Like during lecture,
maybe or maybe just put on the a quiz on the board on the blackboard.
I mean, I give you time to do certain problems, right? I mean, I give you time to do practice problems. Or do you want it to be a grade?
I'm talking about the graded quiz, so we could just go ahead and do maybe after the lesson, or I don't know
Well,
some.
the problem with that is, you see, I have 30 students and only 3 of you guys showed up. So that's kind of defeat the purpose of doing it right after the lesson. So I can't have something like that. But I guess I can post up some more practice questions and have you guys be forced to do it. But it's already like halfway through and I can't really change the syllabus. So if I do that, some people are going to complain. So I can't really
I
I
got
can't
you. Yeah,
really
I
force
hear
you
you.
to do it for a grade. So I can post a question and have it be like practice question, but I can't force it to be a grade.
Yeah. Okay.
Yeah,
Thank you, sir.
yeah, yeah. You okay, Mai? You understand everything? Is that why you're so quiet?
I just looking.
You're just looking. Okay. I hope you're learning, not just looking. Okay, guys. I will see you guys on Thursday. Have a great day. Take care.